So here's some more examples of graphing polynomials. This is example number 1, and I did some of the work already just to save a little bit of time. And f of x equals negative x plus 2 squared times x minus 1 cubed times x minus 3. So it's easy to find the zeros. The zeros are anything that will make the value of the function 0, or that's the vertical position. That means it would put it on the axis. They're also called roots or x-intercepts. And when x is negative 2 plus 2 is 0. And if any factor of a string of factors is 0, the whole thing's 0. So that's going to make the y value. This is also y. I can also write this as y. Equals 0. So if x is negative 2, that's 0. If x is 1, 1 minus 1 is 0. If x is 3, 3 minus 3 is 0. So these would be the zeros. And I could put those on my graph. Negative 2, 1, and 3. Now the y-intercept is when x is 0. So all I have to do is take f of 0. And when x is 0, evaluate this. So if I put a 0 here, I've got negative and 2 squared, negative 1 cubed, and negative 3. And if we work that out, negative and 2 squared is 4. Negative 1 cubed is negative 1, negative 3, so it's going to be 3 negatives make a negative. Negative times a negative is positive, times a negative is a negative. 4 times 3 is 12, so this is my intercept, so I can mark that in. Now, I changed my scale a little bit so I could actually get everything on here, so my scale will be a little bit more biased in order to graph the intercept without having to have an axis that comes way down and uses my whole page. Okay, now let's look at the end behavior model. And all we have to do is, that's what we call our g of x. You could call it e of x for end behavior if you want, or b of x. And this is just a different function that has the same end behavior as this function. So the sign is negative, and all I have to do is add up my exponents. 1, 2, 3, 4, 5, 6. So negative x is 6. So that's negative even. So that's going to behave like negative x squared. There's only 4 possibilities. Positive even like x squared. Negative even like negative x squared. Positive odd, like x, which is just x the first, and negative odd, which is like negative x. So those are only 4 possibilities. So those are your end behavior models. Okay, so we have our intercepts, we got our end behavior, so we should be able to get a pretty good sketch here. So we know it's going to be down and down, like this. Okay, something like that, at least. And now let's see, what are we going to do? Well, we know we're going to, when the exponent is, or the multiplicity is even, we're going to touch and return, or we sometimes say bounce. So at negative 2, it's going to bounce. It's going to go something like this. And then when it's odd, it's going to cross. And it's going to cross at 1. And it's also going to, because 3 is odd, it's going to cross at negative 3. Now, it's going to come down like, so it's going to start lower left because of the end behavior. It's going to come up and it's going to bounce at negative 2. Then it's going to go down around the axis. Now, usually the peak point will be halfway between. So I'm going to estimate that the peak point, the lowest point, will be halfway between negative 2 and 1. So it's about negative 1.5. So, and I'm going to estimate down here. Now, I don't know what it is unless I put that value actually in the function. If I took f of negative 1/2, I could actually find the y-coordinate of this point. I don't want to do that, so I'm just going to estimate it down around here. So it's going to probably come down and peak a little bit to the left of the intercept and then come through the intercept like this. And then it'll come up and cross. All right? So something like that. If I want to find the actual y-coordinate of this point, I would have to put negative 1/2 in the function, take f of negative 1/2, and I can find the vertical position at negative 1/2. We won't do that right now because fractions are kind of not so nice to deal with. So this will come through probably the origin like, the y-intercept like this. Excuse me. Then it's going to come up and cross at 1. And now I'll figure the high point will be between 1 and 3, so it's going to be at 2. And I could put it here. If you put it there, that's not going to be wrong. But if you want to do a little bit extra, I'm sorry about that. If you want to do a little bit extra, so touch and return, cross, lower left, end up, it's coming down like this, so it's going to come from this direction. Okay, then just take f of 2 and to see what the value is at 2. Maybe it is 4, maybe it's 8. So if we put f of 2 in here, every time I see an x, I put a 2, 2 plus 2, 2 minus 1, 2 minus 3. And 2 plus 2 is 4. 4 squared is 16. 2 minus 1 is 1. 1 cubed is 1. 2 minus 3 is negative 1. And that's not too bad. So it's going to be, it looks like it's going to be positive 16. So it's going to come up here kind of high. So I can actually put that in pretty fast. And so that's a checkpoint. But you don't, it's, like I said, we don't have to do that. It's just something extra. So it'll probably come up like that and come back down. And eventually we will be doing things like that, but you don't have to do that right now. Make it kind of symmetrical, you know, quasi or kind of parabolic. And it's going to keep going out. I don't want to dip it in. Sorry about that. That's why you do your sketching in pencil. I can do a lot of stuff in ink, but I got to do my sketching in pencil because, and that follows the end behavior. So something like that. So take a look at that and try to absorb all that information and see if it all makes sense. There's our end behavior. There's our zeros. There's our y-intercept. This is the even multiplicity, so it touches returns, odd crosses, odd crosses. And we actually found the value of this function here. And we kind of estimated this. This could actually go much lower. We would have to put, like I said, we'd have to put negative 1/2 in for x and evaluate that. And we'd have some fractions, cubing, and that wouldn't be a lot of fun. Okay, so that's example 1. I hope that makes sense.